AP, Computer Science Principles, Programming Review. The reviews in this section will cover topics from Unit 4 as well as Unit 5. Each one will be broken up into its own lesson. There are 7 review videos. Throughout these, the following topics will be presented. Students will trace and write code that demonstrates how program code executes commands from top to bottom, including mathematical expressions. Students will trace through the AP exam pseudocode to determine program outcomes, including robot problems. Students will trace and write code that demonstrates how selection using if and if-else statements is used to control the flow of a program and its execution, including nested conditionals. Students will trace and write code involving Boolean conditions. Students will trace and write code that demonstrates how iteration using while and for loops is used to control the flow of a program and its execution, including nested loops. Students will trace and write code that uses procedural abstraction in a program. Students will trace and write code involving the use of data structures, lists, including sequential and binary searches. All of this is part of the programming unit. In this lesson, we will first go through sequencing. There are 3 basic logic structures in any computer language. The first is sequencing. It's an algorithmic structure where all instructions are performed in order and executed one at a time. The computer will run the code in order, one line at a time from the top to the bottom of your program. Selection is a generic term for a type of programming statement that uses a Boolean condition to determine or select whether or not to run a certain block of statements. If, if-else, if-else-if are some examples of these types of selection statements. Finally, iteration is a block of code that repeats to achieve or get closer to a desired goal. Assignment, display, and input. A variable. Think of a variable as a place in memory where you want to store some value. This value might be a number, letter, string of characters, or even a list. In class, we talked about a variable as being a baggie, and into the baggie you may place one and only one value. In many programming languages, you have to have a data type assigned to the variable to let the computer know how big of a space in memory it needs to store the variable. Python, which is used in some classes, as well as JavaScript, are both loosely typed languages, which means that a variable can change type throughout the program. This means that you will not have to declare a variable type anywhere in your program. JavaScript is very much the same way. You need to declare it as a variable, but you don't have to say what kind it is, as it morphs as you use it. In this particular set of review videos, I'll be showing Python. Python and JavaScript are very similar. Here, an assignment evaluates an expression, then assigns a copy of the result to variable A. The AP Computer Science Principles pseudocode. This is what you will see on the AP exam. You have A with an arrow and the expression. Python and JavaScript both have A is set to the value of some expression. Examples evaluate the results of the code below. Notice how the code segments have the AP Computer Science Principles pseudocode as well as Python, and actually in some cases I've changed it over to JavaScript. Either way, the programming code looks very similar to the pseudocode. If we look on the left-hand side, X receives the value of 3, Y receives the value of 4, Z receives the value of X plus Y. So X, which is 3, plus Y, which is 4, is evaluated to be 7, and then 7 is stored in Z. Over here, we have X is set to the value hello, Y is set to the value world, Z is set to X concatenated with Y. Strings are not added like numbers, but they are concatenated. So X concatenated with Y, Z now holds hello world, and notice that there is no space. If you wanted a space, you would have to add it. Okay. Pause the video for a moment and see if you can figure out on the left what is the value of A, and on the right what is the value stored in full name. Did you get 40? And did you get Allison Smith? Notice here, there's that space that I was talking about that was concatenated in. Over here, 3 times 2 is 6. 6 minus 2 is 4. So A now holds 4. So 4 times 10 is 40, and then 40 is stored back into A. Display. Displays the value of expression followed by a space. Because AP Computer Science Principles is language independent, it simply says display and then has the expression which is to be displayed. Know that in Python you would say print and the expression, and in JavaScript you output things to the console log. Okay, if you're just putting it out to the console, you might also put it out in your JavaScript. Okay, on the left is how you will see it on the AP Computer Science Principles. You'll see console log or print and the expression. Either one is pretty self-explanatory. Input accepts a value from the user and returns the input value. So input looks like this in your pseudocode. In Python, name is set to input, enter your name. In the above example, the program will display what is in the quotation marks, then pause the program and wait for the user's input. Once the user presses enter, whatever the user typed will be stored in the variable name. Print, enter your name. Name is set to input. The above statements do exactly the same thing, just on 2 lines. In JavaScript, we're learning how to create an input text box, and then on event, when somebody enters the data and presses enter, it pulls the information in from that on event. These are all ways to get data into your program. Know that on the left here is what you'll see on the AP Computer Science Principles exam. On the right, you can see something like this on a regular test. Arithmetic operators and numeric procedures. Arithmetic operators, plus, minus, multiply, and divide, are used to perform arithmetic. The order of operations used in mathematics applies when evaluating expressions. Modulus is a crazy little thing we have in computers. This is sometimes called the remainder operator. This evaluates to the remainder when A is divided by B. The mod operator has the same precedence as multiplication and division, meaning it happens whenever there's multiplication or division left to right. Random A, B. This command generates and returns a random integer from A to B, including A and B. Each result is equally likely to occur. And I took out what it looks like in Python. We'll talk about it and you will see it in JavaScript. Some examples of modulus. Okay, and by the way, the modulus operator is often the percent sign, which is what it is in JavaScript. But when we're talking about it in the pseudocode, you'll see A mod B. That's the same thing as the percent sign that you will see in JavaScript. 26 mod 2 asks you 26 divided by 2 has what remainder? In this case, 26 divided by 2 is 13, remainder 0, so the answer is 0. 23 mod 5 asks you for the remainder after 23 is divided by 5. Think back to elementary school. 23 divided by 5 is 4, remainder 3, so the answer to 23 mod 5 is 3. Pause the video and try answering the last 2. Did you get 2 and 17? Okay. Notice order of operations. 45 mod 10 happens first. 45 mod 10 has a remainder of 5. So this portion, 45 mod 10, gets replaced by 5. Then you do 5 times 3, which is your 15, and then you add the 2. Order of operations doesn't change. Computers don't change what we already do in arithmetic and math. Relational and Boolean operators. Boolean. A Boolean is a variable that evaluates to true or false. It can also be the value null, which for our purposes in this class means that it is neither true nor false. It has not been given a value yet. AP pseudocode. A equals B, A does not equal B, A greater than B, A less than B, A greater than or equal to B, A less than or equal to B. Pseudocode is more English-like. In Python and JavaScript, we use a double equals to compare equality, an exclamation point equals to compare not equals. The greater than and less than symbols are the same, and then the greater than or equal to, less than or equal to are a combination of two operators. The relational operators are used to test the relationship between two variables, expressions, or values. A comparison using relational operators evaluates to a Boolean value. A equals B evaluates to true or to false. Some examples. X receives the value of 3, Y receives the value of 4, Z receives the value of X equal to B. Now, remember that this over here is JavaScript, so this is comparing X and Y. So is X equal to Y? No, it is not. Therefore, the answer is false. X is set to 10, Y is set to 10. Z is set to the value of X less than or equal to Y. Since they are equal, this will put the value true into Z. Try your hand at this one. Pause the video. Did you get true? A is set to the value of 10 mod 3. 10 divided by 3 is 3, remainder of 1, so A has the value of 1. 1 minus 2 is negative 1. Negative 1 is stored in B. Is A greater than B? 1 is greater than negative 1, so value receives true. Booleans and operators. We have not, and, or. To ensure that there is no confusion on your AP exam, it's actually written out the words not, and or in the pseudocode. In Python, you have not, and or in lowercase, and in Java or JavaScript, we have the exclamation point, the double ampersand, and the two vertical lines. Not switches the Boolean value, and evaluates to true if both Booleans are true, otherwise it evaluates to false. Or evaluates to true if either or both conditions are true, and will evaluate to false only if both conditions are false. Some examples. X receives the value of 3 less than 4 and 6 greater than or equal to 6. Well, first, 3 less than 4 is true, and 6 greater than or equal to 6 is true. True and true is true. So you wind up with the answer true. Over here, Y receives a value of not 3 less than 4 or 5 greater than or equal to 6. 3 is less than 4, so that's true. 5 is not greater than or equal to 6, so that is false. True or false is true, but not true is false. Notice, just like in arithmetic, we work from the inside out. Truth tables. Truth tables are how we show or figure out answers to Boolean expressions. Truth tables are used to help us evaluate these expressions. They start off with 4 rows, each representing the different combinations of true and false values for the Boolean variables. So X can be true, Y can be true, X is true, Y is false, X is false, Y is true, X is false, Y is false. Now, pause the video and go through and see if you can fill out the rest of this table. Are you back? Well, first, not X means that you're going to do the opposite of what X is. So not X is false, false, true, true. False, false, true, true. not y is the opposite of y. So true becomes false, false becomes true, and so on. X and y both must be true in order for x and y to be true. Either is true here. True and true is true. Everything else is false. X or y says if either one of them is true, 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 then it's true. Only when they are both false is the or false. This was a little trickier. You had to not X. So not X means I'm looking at this column, and Y. I'm looking at this column. So true and false is false. False and false is false. True and true is true. False and true is false. Did you get it? The or, X or not Y. X means I'm going to look at this guy. Now let's get rid of these guys. X means I'm looking at this column, and then not Y, I'm looking at this column. If either column is true, then X or not Y is true. So true or false is true. Yay! True or true is true. False or false is false. False or true is true. Did you get them? Hope you did. This concludes lesson 1 and the review of a lot of our basics or sequencing. Next up will be selection review.